let's get our review on for intermediate algebra review worksheet number 2. We have our unit 4 test coming up quickly. So let's review and look at what the areas where we're really gonna need some extra practice. Okay, so number 1, what quadrant is each of the points listed in? So hopefully we know that in Roman numerals, this is quadrant 1, we have quadrant 2, quadrant 3 here, and then quadrant 4 over here. Some people use the method of the C to remember the order. Start here and go around. All right, so here we go. Which one is point A in? Obviously point A then would be in quadrant 3. Point B would be in quadrant 2, and point C would be all the way over there in quadrant 4. Okay, a little bit trickier concept coming up now. What we do is we have an ordered pair here, but we don't know what the x value is, all right? So I just want you to think about it. You know, if we had the x value 3, negative 2. If we had the x value 3, negative 2, we would go right 3 and down 2. So on this problem, we know that we're going to go down 2. We just don't know if we're going left or we're going right. So if I'm going to my graph right now, I'm going to start at the origin. I could go right. I could go left. But I do know that I'm going to go down 2. So I know I'm going down. I know I'm going down. Now it says x cannot be 0. So again, when I look at my graph, and I get a finer point here, I know I'm going left or I'm going right. I'm not going 0, but I could be going down. So I know, I am going down. So I know I'm going down. So that puts me in the quadrants either 3 or quadrant 4, because it could be in 1 or 2 quadrants. So this one is definitely a trickier concept. You got to understand the concept to understand the problem. 3, I believe, is even trickier. The one thing is, if you understood number 2, you know that we're going left 1. You just don't know if we're going up or down, because that's what the y value says. So you know you're going left 1, and then from left 1, you're either going to go up or you're going to go down. Now, the tricky part here is that they're saying, hey, I know this, which means if you take the x value times the y value, you will basically get a positive number because it's greater than 0. So if you look at your x value right now, your x value right now is negative 1 comma something. We don't know what it is. But this is saying, hey, if you take the product or you multiply those two together, you better get something that's positive. I'll tell you right now, if I put a positive here, let's just say I put a 3, that means that you take the product and get a negative. So what we'd have to do is put a negative y value there so that they multiply to give you a positive. Don't forget, we know we're going left 1, and now we don't necessarily know we're going down 3, but we know we're going down because it has to be negative. So we're now going to go, hopefully this makes sense, we're going to go left 1, and we're definitely going to go down. Well, if I'm going left 1 and down, no matter how far down I'm going, I will be just in quadrant 3. And we will continue to try to practice those. Those are tricky ones, for sure. Okay, now this learning target says we can construct a table of values and then graph a linear function. So we do know, we're starting you off this year with linear functions that we're graphing. We do know that we're going to have a line here. All right, so the way we're doing these are just very simply saying we have an x value as input and we have a y value as output. So if we plug in an x value, the one we always want to pick is 0. That's a great one to pick. If I put a 0 in for x, negative 1/5 times 0 is just 0. We'll have a y value of negative 2. So I'm going to plot my first order pair of 0, negative 2. Now the directions have been saying all unit long here that we want to do at least 3 values. You truly only need 2 values to graph a line, but we're going to put 3 values out there. Now it's very smart to look here and see what a nice value would be. If we put in a 1 right now, okay, that would be negative 1/5 times 1, which is negative 1/5 minus 2. I'm going to get an ugly fraction here. It's not that that's not doable. It's not that you can't do that, but it's not a great point for us to plot. So what I'm going to do is I'm actually going to say, okay, what's the y value here when I actually have an x value that works out nice? Well, I'm going to pick an x value of 5. I'm going to multiply by 5 over 1 minus 2. And I hope you see why I did that, because now I have these 5s canceling, leaving 1s. So what I have here for my y value is, and be very careful, negative 1 times 1 is negative 1 minus 2. I got a negative 3. So when I put in, sorry, we didn't do that one, remember? When I put in a 5 for my x value, I'm going to get a negative 3 out for my y value. So that means I go over 1, 2, 3, 4, 5, 1, 2, down 3, and there's another point that's on our graph. All right, so we need one more, and if you thought 5 worked nice, how do you think 10 would work? So if we put in 10 here, so now I'm doing y equals negative 1/5 times 10 minus 2. And then 10 over 5 reduces to 2 over 1. So now we're getting a y value here of negative 2, subtract 2, and that's coming out to negative 4. So 10 plugged in gives me a negative 4. So when I go to my graph now, I'm going to go right 10, and I'm going to go down 4. And that one's kind of, yeah, the graph's not the greatest here, but we'll put that right there. Okay, so now this is very important, even though it's going to look probably terrible on my graph. This is very important that you understand that we are not done until we connect these points. This says to graph the linear function. We're graphing this right here. We're not graphing just the 3 ordered pairs that we happen to choose. All right, that's way different. Watch my pen here. It's way different than this problem. This problem says I only have 5 ordered pairs. That's all I have. This has an infinite number of ordered pairs. So what I'm going to try to do here, and this is not going to go great because of the program, but I'm going to try to connect those, not too bad, and I'm going to make a line through there. Obviously, I suggest you use your straight edge on that, but that's the line to sum up what we did. And it's always a good idea for you to also name your ordered pairs, and a lot of you have been liking to do this. So you put a little A, a little B, and a little C off to the side. Got no problem with that. So you can put your A next to your point, put the B next to the point that we did there, and then C next to that point there. So that's fine. All right, moving along. Now the new directions are saying, can you determine domain and range? So this is where the unit started to get a little bit tricky. When I ask you domain, you might just say, it's the x values. Well, on a problem like this, it is essentially the x values that are in your set. So when we look here, and I'll go with a yellow highlighter here, all of the x values are negative 3, 4, 1, 5, and negative 3. Well, I already had negative 3. It's a set of numbers, so I already had negative 3. So when I do my domain, it's the bracket that looks squiggly like that because it's set notation, and you're just giving me your x values. Well, the smallest x value is negative 3. Well, I'm not going to actually put negative 3 again because it's already in my set. So negative 3 is in there, and we have in order 1, 4, and then 5. And again, they don't have to be in order. This is not interval notation. This is just a set of numbers. But traditionally, you will see them in order. Okay? And then range. I'll grab the green highlighter here for you Green Bay Packer fans out there. So we can go like this on our range, and we know that those are all the y values. Okay? So when I'm going to do my range, I'm looking at the green, and the one that's furthest left looks like negative 2. Next one will be 0. These are separated by commas. Then we have 1. Again, I don't have to list it more than once. And then we have 10. So again, we're going to have 4 values for our range. Now, function yes or no. You're getting really good at these as far as the vertical line test. Some of you are drawing the connection to repeated x values here, which is really important. If you notice that we have a negative 3 in our domain, and it's repeated twice. Well, what that means, guys, is if we were to go to graph, and I'm not going to graph every point here, but if I just graph this first one, it would be negative 3, 0 would be right here. And then if I graph negative 3, 1, it would be right on top of that. Well, you can see if I go ahead and do a vertical line, whoa, sorry, that's hard to do. A vertical line test, all right, let's get rid of that. Sorry about that. But if you can follow my pen here, a vertical line test through here, there we go. It fails the vertical line test. So if it fails the vertical line test, it is not a function. Okay? We're going to move on to page 2 here. Page 2 starts us up at the top here with more of these domain range function yes or no. These are the graphs that get a little bit trickier because we actually have to look at a graph. Well, domain is all of the x values that will actually produce an ordered pair on your graph. So -1 is producing a y value of 2. 0 for x would produce an ordered pair like right here. 1 would produce an ordered pair. 2 would produce 3. Every x value this way will actually produce an ordered pair on that graph. Nothing over here to the left of -1 will produce an ordered pair. So what we say is we actually use this bracket now for our interval notation. We say -1 is the first x value that will produce an ordered pair. And if we go to the right to infinity, we will get every x value producing an ordered pair. That's interval notation. Okay, and then the range is just up, down. So really, if you look at range here, let me try to highlight. If you look at range, the highest this graph is going to get is up here. But we will hit every y value down. Okay, so what that means is, as far as our range goes, we have to start where? Well, we start with our smallest value. The smallest value this graph is going to get in the range is -infinity. Think about it. -1 will be like here, -2 here, -3. It'll keep going down to -infinity. Well, again, with range, we always go down, up, smallest to biggest, just like domain was left to right, smallest to biggest. So -infinity, and we're going to go all the way up to the highest this graph will get is 2, and we will put a bracket because we included 2. And if we do a vertical line test on this, hopefully we see it passes, and this is a function, passes the vertical line test. Okay, looking at number 7, with that, arrows off a little bit here, but with that in mind, vertical line test, I'm just going to answer this question right away. This is also a function because it passes the vertical line test. Now the domain, if we look to the left forever, we will get ordered pairs up here. If we move all the way to the right forever, we will always have ordered pairs. The domain of this one is going to be -infinity to infinity. You will get a value every single place for the x value. All right, range, down forever, up forever. There we go, exact same thing. The range is -infinity to infinity. All right, so moving along here to questions 8 and 9. If you look at question 8, we got to get this into function notation. Well, it's simply a different notation. That's all it is. So we're going to replace the y with f of x. But we don't do that until we actually have the y all by itself. Okay, so we're going to divide both sides by -4. So it now says y is equal to -3/4 x. Well, that's not done. We're going to replace this with f parenthesis x, which is read f of x. All right, so f of x equals -3/4 x. This is a learning target. We're not trying to, not trying to make it a very complicated learning target, just for you to really understand that function notation is written like this. Means the exact same thing as this. If you put in an x, you get out a y. If you put in an x, you get out an f of x. Same thing. Okay, and this one over here, traditionally most of you will subtract x to both sides first. But be careful, that's a opposite of y on the left and a 13 minus x on the right. And then what you're going to have to do here is divide by -1. Notice some of you want to divide by y here. It's not y that we're dividing by, it's -1. So we get y equals 13 divided by -1 is -13 and then plus x. So function notation is f of x equals -13 plus x. All right, all function notation means is it's a fancy way of saying, hey, I want to put in an x value and get out a y value. All right, so what that means here is if this were to say y equals on number 10, if I told you what x was, could you find y? That's all we're doing right here. So on this one, f of -2, you're going to put in a -2 wherever you see x. Well, in this problem, that would be in the numerator, -2, and it would also be right here in the denominator, -2 squared plus 1. Note that some of our previous learning targets are coming into play, and we're putting the -2 in parentheses down at the bottom. So this is, once we evaluate it, going to be -2 on top, and -2 squared is actually 4. And when we add 1, we get 5. So the answer to this problem is just the value -2 over 5. And then f of 1, same thing, except we put a 1 on top, we put a 1 in parentheses on the bottom and square it, we add 1. So this is going to come out to 1 on the top and 2 on the bottom. That's just going to be the answer of 1/2. All right, and then moving along here, same exact thing. Hopefully you can see here that f of 0, if we, I'm not going to have enough space there, so I'll put it right here. F of 0 is equal to 0 squared plus 2 times 0 plus 5. So what that equals is 0 plus 0 plus 5. So f of 0 here is actually the value 5. All right, f of 3 is a little bit trickier because we have a value other than 0. So 3 squared plus 2 times 3 plus 5. 3 squared is 9 plus 6 plus 5. And when we add across left to right, we actually get 9 plus 6, 15 plus 5. We're going to get 20 for interval notation. I'm sorry, for function notation on that one. Okay. Going on to our last few learning targets here. Here we go. I'm going to try to make this one video. Hopefully it won't be too long, big on the YouTube, and we can get one video going. Number 12 on this one. Looking at x and y intercepts, we basically want to plug in x intercepts, and you got to get this definition down. Look back at your notes, please. The x intercept is the x value when y is 0. So if I'm working with the x intercept here, all right, the x intercept is the x value when y is 0. So it's a little trickier on this one, but I'm literally replacing the y with 0. So then if I add 3, now I'm just solving it. So if I add 3 to both sides, I'll be at 3 equals 1/2 x. Now if I multiply both sides by 2, I'm just solving here, I'm going to get an x value coming out to 6. Well, intercepts, we have been teaching you and asking you kindly to write them as ordered pairs all the time. So the x-intercept is 6, 0. Now the y-intercept is way simpler. I mean, look at this. If you do the y-intercept and you put in a 0 here, that's just going to be gone. So you're actually going to have y equals -3 that fast. So what that means is you have 0, -3 as an ordered pair. Because the x value is 0, the y value is -3. All right, we call this the cover-up method. So if you do the x-intercept here, look at this. Essentially, what am I doing? I'm putting in 0 for y, so I'm getting rid of that. So I basically have here, if I get rid of that, I'm going to have 3x equals 6. Divide both sides by 3, I'm going to have x equals 2. So the x-intercept here is going to be 2, 0. Same thing with the y-intercept. I put in 0 right here, it's gone. And I have the opposite of y equals 6. Well, when I solve that, I'll actually get a y value of -6 by dividing both sides by -1. So my y-intercept here is going to be 0, -6. Okay, one more, 14. We threw one on here just so you're not freaked out by the f of x. Remember, f of x literally just means y. So what we can do now is find our x and y intercepts just like we would as if that said y. So find the x-intercept, the x value when y is 0. So really, this is where we're at. It's a tricky one again. But I'm going to subtract 1 from both sides. And then I divide both sides by -3. And I'm going to get here 1/3 equals x, because the -3's cancel. So the x-intercept here is going to be 1/3, 0. All right, y-intercept. Well, looking up here, that's the y value when x is 0. So if you look up here, putting in 0 for x is just going to get rid there, and my y-intercept is actually just going to be 1, using that cover-up method. Very important that we understand where these are graphically as well. So on the graph here, I'll highlight in red, where do we see x and y intercepts? Well, hopefully we understand that this value here and this value here are actually x-intercepts. By definition, those are the spots where we have an x value when y is 0. Remember, y goes up or down none. So -1, -2, -3, -4, -5. So one x-intercept is -5, 0. And the other x-intercept here is at -3, 0. Now where's the y-intercept? Hopefully you can see that actually way down here where it crosses the y-axis, which is actually, hold on, right here. It's kind of hard to see on my graph here, but there's -1. Here's the y-axis. So that actually has what? Down 1, down 2, down 3. So the y-intercept here is actually left or right 0, and then -3. All right, we are almost done with this review. We've got one more learning target to talk about, and once you get the hang of it, I think it's one of the easier ones. Basically, all it's saying is, here's a graph. If you're gonna go graph this right now, I wanna know if this is on the graph. Well, if we were looking at the graph, we'd be able to easily tell whether this is on the graph. But since we're not looking at the graph, we're gonna do it algebraically. And all you do here is you plug this in for x and this in for y. And remember, if you see f of x and it's confusing you, just change it to a y. It's the exact same thing. All right, so here we go. What we're going to do is we're going to say, all right, x is 3, y is -7. So I'm just checking to see if it's true or false. And then I'm just going to say, yes, it's on, or no, it's not. So I have -7 equals 2 minus, and then I want to take 3 and I want to square it because it's my x value squared. So I've got -7 equals 2 minus 9. And hopefully you can see that that's a true statement. -7 does equal -7. So since it's a true, don't forget your answer here is yes, it is on the graph, or it is a solution to the equation. All right, so here we go. Try it again. Our y value is 1 this time. Equals 2 minus, be very careful here, -1 squared, -1 squared. So when we do the actual squaring correctly, we get 2 minus -1 squared is actually 1. And that is 1, does 1 equal 2 minus 1? It absolutely does. So this is also a solution. Sometimes there's more than one. All right, next one, finally here, we have the -4 as the y value. So we're going to have -4 equals, and we put the 6 in for x in the two locations. 6 over the opposite of 6 plus 4. And we're just going to go through and see if this is true. On the top we have 6. On the bottom we have -2. So is 6 divided by -2 actually equal -4? No, it is not. So we would say, no, this is not a solution. All right, then finally, last one. We have -1 equals x on top, so that would be 0 on top. And on the bottom, we're going to have the opposite of 0, plus 4. Well, -1 is equal to 0 over 4, really. And 0 over 4 is really equal to this right here. Is really the same thing as 0. So does -1 equal 0? No, it does not. Please don't, don't think right now, oh, well, that means they're either both yes or both no. You're drawing conclusions that aren't necessarily true. If it comes out to a true statement, it is. If it doesn't, it's not. And there's many order pairs we can give you. Just checking that test to see if it's true or false on that one. Okay? Remember, we are here to help you. I hope that this has been helpful to you. I hope that if your frown is down, you can learn math and turn it upside down. I don't know, something like that. But please, we are here to help you. Just ask for the help, guys. We'll help you outside of class. Thank you so much for watching this video. Tell me in class you watched it. I'll give you a high five. Have a great night.